Okay, today's lesson is on properties of logarithms, 7.4. So what we're going to do is if we understand that, remember that logs are exponents and logs behave just like exponents, we can understand that there are a few rules and a few properties that logs will follow that are similar to exponent properties. So for example, most of these exponent properties you should already be familiar with, but the first exponent property is the multiplication property, or the product property. So this is where you would have a to the m power times a to the n power. So when we were doing exponents, when you were multiplying things with the same base, what did you do with your exponents? Yeah, and you added them. So it's m plus n. So when you have the same base, you can, if you are multiplying in the same base, then you would add the exponents. Well, a similar property for logs is that if I'm multiplying things within a log, so some log, that's log, it's terrible, let's try that again, log, jeez, log with some base of m times n, so I'm multiplying two things, you can actually expand it to be of log base b plus, or sorry, log base b of m plus log base b of n. So notice that in the product property with exponents, if I were multiplying things with the same base, you added the exponents. Here I'm multiplying logs of two different things that have the same base, so I can add them. This is called expanding logarithms. So going this way, going from this to this is called expanding logarithms. And then if I were to go this from here to here, it would be called condensing logs. And we'll go both ways today. But understand that if you can just understand that it behaves just like exponents. So if I'm multiplying, it turns to addition. And we can see an example below. So if we want to do this first example, we can do that. So if we have log of 10x, what we really have is the log of 10 times x. There's a little multiplication symbol there. So what we can do is sort of separate these into two separate logs. Because it's multiplication, we can write this as log of 10 plus log of x. So just expanding it using those properties. All right. Another exponent property is the quotient property, and this is where you would have a to the m divided by a to the n. So where you are dividing things with the same base, what did you do with the exponents here? Yeah, you subtracted them. So you would do a m minus n. So a similar rule applies when you're doing logs. If you're dividing two things with the same base, so for example, if I had log of whatever base of m divided by n, because both of these have the same base b, and it's division, I can actually expand them into subtraction. So what this would look like is log of some base of m minus log of the same base of n. So I can change over division into subtraction. And finally, the last exponent property is a power property. So this is where you have a power to a power. So this is where you would have a to the m to the n. So you have a power to a power. Now what did we do with the exponents here? Yeah, we just multiplied them, so it'd be m times n. So when you add a power to a power, it was m times n. So a similar log property is if we have a log of some base of m to the n power, so I have a log base of something to a power, we can change it to multiplication by bringing our exponent down in front. So what this looks like now is n times log of some base of m. So a little bit more of a reach with this property, trying to see that, but understand that you have the power, the exponent out here, and you're going to distribute it. It becomes multiplication of these two. Here you have a power that's above here, so this moves out front to become multiplication of those two things. A little bit, again, a little bit more of a reach, but you'll get the hang of it when we do a few more of these. Okay. So let's do some practice problems. The first thing we're going to do is expanding. Now, we already expanded the first one, so we're going to expand a few more of these. Change colors here. So the first thing you're going to want to do, so I have multiple things here. I have like sort of this, and I have this, all going on. What you're going to want to do is you're going to want to separate multiplication first. So I have multiplication in there. That's multiplication. So I'm going to separate those two. Multiplication separates out to addition. So this will be the natural log of 2 plus the natural log, that's not a natural log, there you go, natural log of x to the 6th. But then we have another property. I have an exponent here. And when you have an exponent, remember that exponent can be dropped down in front and changed over to multiplication. So now what I have is the natural log of 2 plus 6 times the natural log of x. And that would be that fully expanded. Try one more. I think one more, yeah. We're not going to do D, so but one more of this here. So now here we have division. So we have this sort of division line here. So I can separate those out. Division separates into subtraction. So I can have log base 3 of x to the 4th minus log base 3 of 3y to the 3rd. Couple things can now happen. And I have an exponent here that I can bring out in front. Over here I have multiple things, so I do have to separate that by multiplication first. So I'm going to bring over the exponent. So this is 4 log base 3 of x minus, now I'm going to separate this entire quantity here. So I'm going to put this in parentheses. Let's see if it'll, it's like freezing on me. There you go. I'm going to separate those. Since that's multiplication, I can separate this out into addition. So it's log base 3 of 3. And then plus log base 3 of y to the 3rd. And then further, I have an exponent that I can bring out front. So let's write this as its final answer here. I have 4 log base 3 of x minus the quantity log base 3 of 3 plus the 3 that's moved out front, log base 3 of y. And that is its full expansion. And that's really as hard as this is going to get. A couple things to point out. You might be thinking, why the heck are we doing this? Why would you expand a log like this? Now, I'll tell you, I'm going to be honest with you, this does not happen very often. You normally don't take a condensed log. Let me bring this up here. You normally don't bring a condensed log like up here and then expand it. But one of the uses of expanding it is there's some things that you can then cancel out. If you notice here, I have log base 3 of 3. And if you remember from what we did last class, when you have a log base of the same number, it actually is just 1. So this would simplify because, and the only reason you would know this is because you expanded it, and this would be 1. But other than that, there's not a lot of uses to expanding. We just use it to sort of practice our rules, where the real things that you're going to see are in condensing logs. So I'm not going to do the last one. That's a little overkill, so I'm not going to pay attention to that one. But where you're going to see the real stuff here is in condensing, because when we move on to the next couple cycles where we're going to be solving these logarithms, the only way to solve them is if they are in condensed form. So this becomes much more important that we know how to condense logs, because without being able to condense them, we can't solve them. So basically we're going to work backwards. Let me change colors here. Noticing that you have the same base with addition, working backwards, 2 logs added is actually the same as 2 logs being multiplied. So you can actually multiply the 2 logs. So this becomes 1 log of log base 2, and then 8 times 3x. And then you can actually multiply that. So it would be log base 2, 8 times 3x is 24x. And that would be your answer. So just understanding your properties. Here I have subtraction, but I also have one more thing too. I have a number, I have a coefficient out front. Remember, the only way to get a coefficient out front is if it was an exponent. So we're going to put it back in as its exponent. And so I'll just do one step at a time. So I have log base 5 of 4 minus, that 2 is now going to go to the exponent, so log base 5, come on, freezing on me here, there we go, log base 5 of 5 squared, and actually you can even do 5 squared, which is 25. Now we can work with this subtraction sign. The subtraction sign translates to, with logs, division, so we can actually divide these two things into one log. So there'll be one single log of 4 over what is now 25. Okay? Just a couple more and we'll be done. Okay? Another set here. So I have a coefficient that is supposed to be an exponent. So combining this would be the natural log of 6x to the third plus the natural log of 4y. Since they're both natural logs in the same base, and this is addition, I can change this over to multiplication and combine it into one log. So this will now be the natural log, and got ahead of myself, natural log of 6x to the third times 4y, which is 24x to the third y. And finally, the last one here is going to be, now we're going to do all of these things. So a couple things, we're going to take care of our exponents. So that 4 is going to go there, in which you'll have log of 3 to the 4th, and 3 to the 4th I think is 81. And then we're going to do work from left to right. So we're going to work first with the addition. So that means I get to multiply these. So 6 times 81, so I have log of 6 times 81, which is like 486, I think. Sorry, I know that off the top of my head. 6 times 81, 486, it is 46. So log of 486, and then minus log of 3, and now I deal with the division. So this is subtraction, so it turns to division. So I can turn this into one single thing by dividing 486 divided by 3, which is 162. And that would be your final answer. So just to sort of, let's zoom out now. Those are our log properties. Please, 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 please practice your log properties. It's going to become important when we go to solving. You have to be able to do this. I know we only did like 7 problems, but there are a bunch more in your practice that you should be doing. As we see the second page here, we might be concerned as to, oh, another page, but we've actually already done this. So this is the change of base formula. Basically, it states that if you don't have a fancy calculator, in our fancy calculators, we can just take this, go to math and go to log base, and we can change the base and hit 77 and hit equals. But remember, if you have an older version of a TI or a Casio, you will have to do the change of base formula, which is to do log of the larger number. By larger, I mean like physically larger, not quantity larger, divided by log of 8, log of your base. And that will give you the same answer. That's all this is talking about, and we've already addressed this. So thank you. Let me know if you need any help.